Hello friends, this is Durga from IT Varsity, a one-stop shop to learn all the technologies. So as you guys are aware of, I typically create videos in the form of playlists, and one of the playlists which I'm pursuing at this time is CCAH, as well as setting up Hadoop on setting up Hadoop on AWS as well as virtual machines. In that process, one of the important thing which you need to understand is schedulers. So schedulers is the one which will take care of submitting simultaneous jobs and handling those jobs effectively. So let me go back to the presentation. So as part of the schedulers, first we need to understand the overall design. I have to share the screen. Just give me a minute. Let me share the screen here. Screen share, entire screen, share. So you will be able to see my screen now. And now I'll go back to my presentation. And here is the topic which we are talking at this time. So as part of this, first we will try to understand Hadoop schedulers at a higher level. Why we need Hadoop schedulers? So for that, I will directly get onto the cluster and try to demonstrate why we need schedulers. Okay. So I'm actually connecting to my AWS, my CDH cluster, which is running on AWS. So this is my IP address, a public IP, which I'm connecting. And now I'm inside the cluster, the gateway node of the cluster. This is a 7-node cluster where we have 4 nodes running data nodes and node managers. And here I will try to run a word count program on the data which I have generated earlier. So as you guys are already aware, if you are following my videos, there is a Hadoop examples jar file which you can find by running find command. If you log in as root, you can directly say find slash name Hadoop star examples star.jar, and it will give the jar file name. If you hit enter, it will list all the jar files which have Hadoop examples in them. So earlier I have ran this program called Hadoop jar Hadoop map reduce examples.jar. Random text writer is the program or application which I try to run, and it will actually generate 10 GB worth of data for each node in the cluster. So as we have four data node cluster, it will generate 40 GB data in this path, user root random text writer. We can validate that by running Hadoop fs-ls /user/root random text writer, and you can see there are 41 GB files. You can also run du for disk usage, s for summary, -h for human readable format. So let me move this thing a little bit aside, and you can run this command to see the size of the file. The size of the file is 41 GB. And the block size, if you follow my videos, block size is the one which will typically determine the number of mappers. By default, if we have 41 GB, it will be around 8 into 40, around 320 blocks will be there for these files. That you can run hdfs fsck user root random text writer, and then you can say files blocks and hit enter. It will give the list of the blocks for all the files we have. Okay, you can see there are 360 blocks for these 41 1 GB files. So it will try to create 360 mappers to process that data if we try to run any application on top of this data. So I will try to run a program called word count on this data set. Again, word count will be part of this map reduce examples jar file itself. And here I am trying to run the program word count on user root random text writer /user/root/word count, which will actually Actually, I did incorrect. Let me see if there are any jobs running. So there is nothing running right now. We can also validate from the web interface. For that, you have to get into SSH tunneling. So this is how you can start SSH tunneling, and then you can start Foxy proxy, which I have enabled on my Firefox. So I'm using Firefox here, and then I can use my resource manager web interface. Now I'm trying to log into Cloudera Manager to get the resource manager IP address and port number. So I logged into the cluster using Cloudera Manager. Here I should restart HDFS so that my cluster will come to healthy state. So to confirm whether there are any jobs before submitting the job, you can go to Resource Manager Web Interface by clicking on this yarn MR2. By going to Web UI, you will get the Resource Manager Web Interfaces. So you can use this one to log into the cluster. Sorry, to log into the Resource Manager and see if there are any jobs that are running. Okay. So here we can use the private IP address now. So IP-172, I think this is the IP address which will give the current running jobs. As of now, there is no job running at this time, so we'll start that job in a moment. Okay, so now on this cluster, once we make sure that it came back to the normal condition, we can actually start running the jobs. There are some alerts here. I think these will go away in some time. I think everything looks good, so we can actually submit the MapReduce job on this cluster. So here I'm trying to run this word count application without NoHub so that it actually run in the foreground itself. So why I'm explaining all this is to build the case for the requirement of the schedulers. Okay, now I ran this single job on the cluster, which requires 360 mappers. So now you can see that it is starting the job. It has generated the URL. You can copy this URL and go to the Firefox where the Foxy proxy is running and check the status of the job that is running by going online. You can see that it's a map one. It's a job which requires 360 mappers and 8 reducers. And if you look into the details of it, if you see these 360 mappers are not submitted at the same time, because our capacity is limited to 16, and one of the 16 capacity is taken care by application master to submit this job, and rest of the 15 is actually processing the data. So once the mappers are about to complete, then reducers will start. Until then, only mappers will progress. Okay, I think by default, once 90% of the mappers are completed, then only reducers will start processing the data. Until then, reducers will be waiting. So even for a single job, when it requires 360 capacity, but our cluster capacity is only 16 because we have only 16 vCores, it cannot go below 16. The capacity will be at least 16, and actually this is at max 16. It cannot go beyond 16 mappers at a given point in time, or 16 tasks at a given point in time. I have explained that earlier when I have covered MapReduce plus yarn in detail, how these numbers are determined. Anyway, for now, just remember that this cluster can only run at max 16 containers, which runs the map tasks and reduce tasks. And you can see that here. There are 15 tasks that are running at a given point in time, plus one for application master. Okay. So this will be changing between as the tasks are being completed, the pending will be moved to running, and if you add pending plus running plus completed, uh, will be equal to total, and then the total capacity will be determined by all the running tasks for all the jobs plus application masters. So right now there is one application master and up to 15 tasks that are running at a given point in time, and this number will change. It will stuck at 15. As of now, the jobs are more frequently being completed and then running. That's why it reduced to 12, and now you can see that it came back to 15. So this is with respect to one job. And in a busy cluster, there will be many jobs that will be running like this, not just one job. And that's where the requirement of schedulers comes into picture. Okay. So let me stop presentation. That's where the requirement of schedulers comes into picture. So there are three types of schedulers which will take care of handling tasks from multiple jobs. One is FIFO scheduler, which is default, and the other one is phase scheduler and capacity scheduler. So you need to understand how the programs will be executed with these three schedulers, and we will see that as part of further videos. Here I just build the case about how to run the jobs, and then the relevance of schedulers, which you need to get into the details. So we will try to understand how FIFO schedulers run, how capacity scheduler run, and how phase scheduler run. FIFO is default in Apache Hadoop. We don't use it typically in production clusters. In production clusters, either we use phase scheduler or capacity scheduler. And phase scheduler is default in Cloudera distribution, and capacity scheduler is default in Hortonworks. And here we are talking about Cloudera distribution of Hadoop, and hence it will be better for you to emphasize more on phase scheduler than capacity scheduler, especially if you are trying to give the certification, because there will be bias from the vendors where they will focus on the stuff which they support. And on top of that, this is a very small topic with a good amount of weightage if you are trying to give CCAH certification. So make sure you understand all the nitty-gritty details about FIFO scheduler, phase scheduler, and up to considerable extent in capacity scheduler, so that you can answer as many questions as possible. That being said, we will be talking about each of the schedulers in detail as part of next few videos, so that you can understand the concepts behind it. And there will be scenario based questions in this topic, which you should be able to answer very easily once you understand the basics behind them. Thank you. Bye.